Let us find the unique matrix A prime that is row equivalent to matrix A, 3, 1, negative 1, 6, 1, negative 2, 3, negative 6, 0, negative 3, 2, and negative 8. So let us rewrite A, 3, 1, negative 1, 6, 1, negative 2, 3, negative 6, 0, negative 3, 2, negative 8. This is our pivotal column. And the first entry that is not 0 is a 3. That is our pivot. But we see that there is an entry along that column that is already equal to 1. So instead of multiplying the first row by 1/3 to turn 3 into a 1, we simply interchange rows 1 and 2. Okay, so we interchange row 1 and row 2. Thus we have 1, negative 2, 3, negative 6, 3, 1, negative 1, 6, 0, negative 3, 2, and negative 8. Alright, so we now have a leading entry. This is a leading entry. So it is found along the first column, so entries below must be 0. So we need to turn 3 into a 0. We rewrite the first row, 1, negative 2, 3, and negative 6. We multiply row 1 by the additive inverse of 3, negative 3. And then add it to row 2, the result written in row 2. So 1 times negative 3 is negative 3 plus 3 is of course 0. Negative 2 times negative 3 is positive 6 and 1, that will be 7. 3 times negative 3 is negative 9 and negative 1 is negative 10. And negative 6 times negative 3 is positive 18 plus 6, that will be 24. And then we retain the third row y because this is already a 0. So 0, negative 3, 2, and negative 8. Alright. So for the meantime, we forget about the first row. Alright. Forget about the first row. And then identify our pivotal column, 7, negative 3. And the first non-zero entry is a 7. And that is our pivot. And we need to turn this pivot into a 1. So what we will do is we will multiply this by 1 over 7. Okay, so we will multiply row 2 by 1 over 7. Okay, and what do we have? We have 0, negative 10 over, okay, should be 1. 7 divided by 7 is 1. Negative 10 over 7 and positive 24 over 7. There. So we now have a leading entry. Entries above and below must be 0. So let me rewrite the elements of the first and the third row. 1, negative 2, 3, negative 6, 0, negative 3, 2, and negative 8. So these entries must turn into 0. Okay? So we multiply row 2 by, let's start with negative 2. So additive inverse is positive 2. Then add it to row 1. Okay? So 0, 1, negative 10 over 7, 24 over 7. So 0 times 2 is 0 plus 1 is 1. You can see that the leading entry of the first row is unchanged. No? Then 1 times 2 is 2 minus 2 is 0. Negative 10 over 7 times 2 is negative 20 over 7. Okay, so plus 3. That will be 21 over 7. Negative 20 over 7 plus 21 over 7 is 1 over 7. Then 24 over 7 times 2 is 48 over 7 minus 6. So 6 becomes 42 over 7. So 48 over 7 minus 42 over 7 is positive 6 over 7. Okay? Then let us erase this. We need to change negative 3 into a 0. So multiply row 2 by the additive inverse of negative 3 is positive 3. Then add it to row 3. Return it back to row 3. This one returns back to row 1. So 0 times 3 is 0 plus 0 is still 0. 1 times 3 is 3 minus 3 is 0. Negative 10 over 7 times 3 is negative 30 over 7. Add it to 2. So that will be 14 over 7. Negative 30 plus 14 is negative 16 over 7. Okay, then 24 over 7 times 3, that will be 72 over 7 minus 8. 8 becomes 56 over 7. 72 minus 56, that will be 16 over 7. Okay, erase this. Alright, so we now go to the third row. Okay, so forget about the first and the second. Consider the third row. This is the pivotal column. At the same time, that is already the pivot. Alright, so what we do is we just multiply row 3 by negative 7 over 16. Just the reciprocal. To make it into a 1. To change this into a 1. So, third row, 0, 0, 1, negative 1. Okay. Since this is a leading entry, that is a leading entry, entries above 1 over 7 and negative 10 over 7 must turn into a 0. Okay, so we multiply row 3 by, let's start with 1 over 7. The additive inverse is negative 1 over 7. Then add it to row 1, returns back to row 1. Okay, so 0 times negative 1 over 7, 0 and 1 is 1. 0 times negative 1 over 7, 0 and 0, 0. 1 times negative 1 over 7 is negative 1 over 7, plus 1 over 7 is, of course, 0. Negative 1 times negative 1 over 7 is positive 1 over 7, plus 6 over 7. That will be 7 over 7, or 1. Next, negative 10 over 7. So the additive inverse is positive 10 over 7. Multiply it to row 3 and add to it to row 2, returns back to row 2. So 0 times 10 over 7 is 0, plus 0 is 0. 0 times 10 over 7 is 0, plus 1 is 1. 1 times 10 over 7 minus 10 over 7 is 0. Negative 1 times 10 over 7 is negative 10 over 7. Negative 10 over 7 plus 24 over 7. That will be positive 14 over 7, or 2. Okay, so that is a 2. And we see that this matrix is already in the reduced row echelon form. So therefore, the matrix A prime that we are looking for is the matrix 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, negative 1. Okay? Okay. Find A prime in reduced row echelon form that is row equivalent to A. Okay, work on this and I'll be back after 15 minutes.